Okay, real world applications number 3 example is again a maximizing height problem, but this time the difference between number 1 and number 3 is that I'm taking this object and I'm throwing it downward. So I'm giving it an initial push towards the ground. Okay, again, we're going to need to read the problem. Coach Carney heads up to the top of the press box, but realizes that he forgot to give Cameron the keys to open the locker room at halftime. Carney throws the keys down at 10 feet per second from a height of 200 feet. That equation here is given by h of t equals negative 16t squared minus 10t plus 200. And those numbers again come from the fact that we're throwing the object down at 10 feet per second. That's my velocity. Okay, and because it's down, it's minus. And it's from a height of 200 feet above ground. So that's why it's plus 200 at the tail end there. Okay. Similar to number 1, we're going to start by finding the values of A, B, and C. So the value of A here is negative 16. The value of B here is negative 10. And the value of C here is 200. From there, you're going to then find your axis of symmetry. So my AOS is T equals the opposite of B over 2A. And again, we're going to plug in those values there. So the opposite of negative 10 is positive 10 over 2 times the value of A, or negative 16. And then you're going to again simplify. So I have 10 over negative 32, which is going to give me a value of negative 0.3125. Okay, because of the fact that this is negative, and again, these ones should always come out to be a negative AOS. Do not change it positive just to make it positive. It is negative on number 3 for a reason. Okay, and you will not include this in your table, and it will not be included in your graph. Okay, if the AOS is positive, it will be included in both your table and your graph. But here, it is negative, and it will not be. Okay, so from here, we then start our table. Again, the table is going to be an H chart. I'm going to start with T. I'm going to then do the equation H of T equals, we have negative 16 T squared minus 10t plus the 200. And then these are going to be my ordered pairs. What I plug in, comma, what I get out. Okay, that very first value that we're going to plug in is always again 0. And again, I'm going to work them out one by one, because again, I can stop plugging things in as soon as I get an output of 0 or a negative number. Again, then implying that it hit the ground, or the object has then buried itself into the ground. Okay, when we plug in 0, we end up with 0 plus 0 or minus 0 plus 200, which means I have 0 comma 200. We then go to 1. We plug in 1, we got negative 16 times 1 squared minus 110 times 1 plus 200, which gives me a value of 1 comma 174. Okay, so in just 1 second, it's dropped 26 feet. We then continue. I have 2. I have negative 16 times 2 squared minus 10 times 2 plus 200. When you plug that in, work it out, you get 2 comma 116. Continuing to the next 3, we get negative 16 times 3 squared minus 10 times 3 plus 200. And when you work that out, you get 3 comma 26. Okay, again, this is a lower number, but we cannot stop here because we don't have 0 or a negative value out for the output. So you have to continue to the next. 4, negative 16 times 4 squared, minus 10 times 4, plus 200. It's going to give me a value of 4 comma negative 96. Okay, so now again, because I have a negative value, I can stop working them out. Okay, and then I'm going to create my scales using this stuff. So here, I'm going to start again with the H of T scale. I'm going to go back to that ordered pair that has the vertex, or where I plugged in the AOS. However, here again, we don't have an axis of symmetry. Okay, so you're still going to do the same kind of thought process. You're still looking for that largest value of the output value. But here, if you notice, again, because we're throwing it downward, that's the initial release height as well. Okay, so I'm going to go back to this first order pair, and the 200 is larger than anything here. So I'm going to use that 200. So my H of T scale is going to be 200. And again, I'm going to divide that by 4 because of the nice landmarks that I have here. And when I take 200 divided by 4, I end up with 50. Okay, again, if we need to, you can round this to a something that is divisible by 5. It could be the nearest 10 if it's something like this. It could be the nearest 100 if it's in the thousands. Okay, again, do it within reason. I want to see these graphs as big as possible to space out as much as I can on these graphs that I present to you. Okay, so here, 50s, perfect. We're going to go with 0. This next lineup would then be 50. The next lineup would then be 100. Then up we have 150. And then up we have 200. And again, then to help us with further graphing purposes, we look at this and find out how much each individual line climbing up is. We take whatever this value is, we divide it again by 5, and that gives me what each line represents. So 50 divided by 5 is 10. So each line is worth 10 feet. To find my T scale, I'm again then going to use that bottom value of the table that gives me the 0 output or the negative output. So I'm going to use that 4 because this was the one that gave me the negative. I have to use this number. So I have 4 divided by, again, what? 6. Right? 6 because we have 1, 2, 3, 4, 5, 6 nice landmarks on the bottom. Equals 0.6 repeated. Okay, and again, this is not a nice decimal, so we're going to round that off. Okay, we can round it off to the nearest 0.5, but again, it's at 0.6. So we're going to round that up again to 1. So I'm going to have 0, 1, 2, 3, 4, 5, and 6. From here, then, we're going to go ahead and graph all of our ordered pairs. We have 0, 200, so I have an ordered pair here at 200. Then we have 1, 174, so I have 1, 150, 160, 170, 175 would be directly in the middle, so we're just short of the middle. 2, 116, so we have 2, 100, 110, 116 would be just above half. 326, so we have 3, 10, 26. And then at 4, we have negative 96. So obviously I can't graph that one. Again, you're going to nicely, smoothly transition on this curve. Do not get to that bottom point at 3 and then either drop straight down or go as quickly over to 6 as you can, because I see a lot of people do that. You're going to start here at the top. And we're going to go smooth transitions as much as we can, as long as the graph actually graphs, and continue. Okay, again, I do not want to see any arrows down at the bottom there, because we don't want these to continue on forever like most graphs. These are real world applications. Okay, when it hits here at the bottom of this, it means it hit the ground. Okay, we don't want it to continue down further into the ground. Okay, once we have those things, we're going to then find and identify the three things that we need: the x-intercept, or the t-intercept here, the y-intercept, or again the h of t-intercept here, and then the maxima. Okay, so let's start with the t-intercept. The t-intercept is here. If you look right there, this is my t-intercept. And that value is again a between statement, because I don't have something that is actually exactly on that point, right? So I'm going to do that between statement like I did for number 1. This is someplace between 3, which is less than the value of t, which is less than the value of 4, because it goes from here to here, someplace between. And then what does that mean? Again, this means that the object, or here the keys, have hit the ground. Between 3 and 4 seconds. Okay. The h of t intercept here. Again, comes from the top of the graph here, the table. We have 0, 200. That's my ordered pair, so 0, 200. And what that tells me is that this is the initial height. Again, these keys were thrown from a height of 200 feet. So 0, 200 was the initial height. Okay, and then now we're going to find the maxima. Again, the maxima comes from the y value of the vertex typically. Okay, but again here, important to note that we did not graph the axis of symmetry because it's negative. So because it's negative, we still need to have the maxima in relationship to this problem itself. So what we're going to do is, again, look for that highest value of y that's in the table. Okay, we've already used it. It's the 200. Okay, this is my maxima. Okay, but again, it's just the y value of that ordered pair. So this is going to be 200 feet. Okay? And this is because this was thrown down. It will go no higher than the original $200 feet. Okay, and again, although it's a lot of work, it's very closely related to number 1. So if you've been able to figure out number 1 and master number 1, then number 3 should be fairly easy to figure out as well. That's all for number 3. Check out the next video for the example number 4.